Hello! In this video, I'll be talking about nutrition and bone health. Our bones are extremely important for a multitude of reasons. They give our body structure, protect our organs, and help us move and carry ourselves. They also contain red blood marrow, which is responsible for the production of new blood cells. Bones are also the primary way our body stores and releases calcium to maintain homeostasis. There are three types of bone cells: osteoblasts, osteoclasts, and osteocytes. Osteoblasts are bone-building cells that deposit minerals like calcium and phosphate onto osteocytes to make them stronger. Osteoclasts break down collagen in the bone to release calcium into the body by releasing an enzyme called collagenase. From there, calcium is used in a variety of organ systems, including the nervous, cardiovascular, digestive, and muscular systems. For example, calcium is needed to release neurotransmitters in the brain. It's also needed to make muscles contract. This is extremely important not only for movement, but to keep the heart pumping as well. Calcium also helps the colon move water and maintain digestive homeostasis. Two hormones are responsible for regulating the activity of osteoblasts and osteoclasts. PTH, or parathyroid hormone, is a hormone released from the parathyroid glands that causes osteoclasts to break down the bone and release calcium. Calcitonin is another hormone released by the thyroid gland and stimulates osteoblasts to deposit more calcium onto the bone. It's important that we get enough vitamin D and calcium so that we can maintain a balance between these two processes. Vitamin D is an essential vitamin that is needed for the absorption of calcium. Vitamin D is converted into a molecule called calcitrol in the kidney. Calcitrol binds to nuclear receptors in intestinal cells to initiate calcium absorption. Without vitamin D, we would only be able to absorb about 10 to 15% of the calcium we consume. Calcium imbalances can disrupt the functions of multiple organ systems. Hypercalcemia is the abundance of calcium in the blood. Mild hypercalcemia is usually not symptomatic, but severe hypercalcemia can lead to nausea, altered mental status, headache, depression, weakness, muscle pain, and joint pain, as well as frequent urination and excessive thirst to flush out excess calcium. Hypocalcemia, or calcium deficiency, can lead to syncope, congestive heart failure, numbness and tingling, muscle spasms, bronchospasms, laryngospasms, dysphagia, irritability, depression, fatigue, and seizures. It can also lead to neural hyperexcitability, psychological disturbances, and cardiac arrhythmias. One condition associated with hypocalcemia is osteomalacia. Osteomalacia is the breakdown of minerals like calcium and phosphate in the bone in response to vitamin D deficiency. Without vitamin D to help absorb calcium, patients with osteomalacia release more parathyroid hormone that breaks down the bone to restore calcium levels in the blood and other organs. This causes the bone to become softer and weaker. Osteomalacia is called rickets in children. Rickets differs slightly from osteomalacia because it softens the cartilage in the growth plates of bones. Osteoporosis is another bone disease caused by low levels of vitamin D and calcium. Like osteomalacia, osteoclast activity outweighs that of osteoblasts in patients with osteoporosis. However, instead of making the bones softer and weaker, osteoporosis results in the decomposition of bones, making patients more susceptible to fractures and breaks. Osteoporosis can affect anyone regardless of age and gender. However, it's most common among older women. In order to maintain a healthy balance of calcium in our bones, it is critical that we get an adequate amount of it in our diet, as well as vitamin D to absorb calcium. Some foods rich in calcium include dairy products, as well as vegetables like spinach and kale. Many non-dairy milks like almond milk are also fortified with calcium. The recommended daily allowance of calcium is about 1,000 milligrams for adults. It's also recommended that older women increase their calcium intake as they are at a higher risk for breaks and fractures. The recommended daily allowance for vitamin D is 15 micrograms for adults. It's recommended that older people increase their vitamin D intake to 20 micrograms. This is because as we age, our skin can't synthesize vitamin D in response to sunlight as well. Sunlight is the predominant way we obtain vitamin D. However, dietary sources include fish like tuna, salmon, and sardines, as well as egg yolks. Many dairy products, plant milks, and even orange juice are fortified with vitamin D as well. Another important mineral for bone health is magnesium. Magnesium deficiency has been associated with lower bone mass density in postmenopausal women and increases the risk of a break or fracture. This could be because magnesium is needed for the functioning of a variety of enzymes and may affect the activity of bone-building enzymes like propeptide type 1 procollagen. Foods rich in magnesium include green leafy vegetables, legumes, nuts, whole grains, and seeds. Another way to improve bone mass density is through moderate exercise. Moderate mechanical stress on our bones increases osteoblast activity, making our bones stronger over time. This idea has been referred to as Wolff's Law, the idea that bones remodel themselves in response to mechanical stress. One example of this law is the lower bone density found in astronauts after spending an extended amount of time in space. While in space, astronauts can lose up to 2% of their bone density per month in their hips and spine from not experiencing the mechanical stress of gravity. Conversely, weightlifting has been found to increase bone density as a result of the bone adapting to stress. It is important to get an adequate amount of moderate exercise to maintain bone health. Thank you for watching this video, and please feel free to look through my resources, as well as conduct some research of your own on how our nutrition and activity affects our bone health.